Okay, let me take the microphone. I also like to contribute to this session about quantum technologies, and I may have a very different viewpoint to this in comparison to a lot of the participants of the conference, because they are coming from fundamental science, from research. This is also my background, but since about 10 years I'm managing a company. I have about 120 people, and our mission is to transfer results from scientific projects into industrial applications. So our customers are very innovative companies which are looking for new solutions. And in this case, I'm first of all responsible, of course, for the 120 people and for the success of the company. So most of our, let's say, successful business is based on classical but very advanced products based on semiconductor technology. But nevertheless, we are looking for the next generation of solutions. So we have three current activities which are based on quantum technologies, and we're also looking for those who have the potential to go to applications soon, because this is something which will be also very encouraging for young researchers, but also encouraging maybe for funding agencies to see that their money is going into some real products. So that's why I'm not addressing maybe some very advanced nanomaterials or things like this, but I will tell you the three different fields we are working on. So one is the quantum-based gravimeter. It's a sensor to detect holes or modes under the ground, and it's working in a quantum regime because the ratio of mass and spring constant is already in a quantum regime. And this was proposed about 10 years ago by a British group, and they showed maybe 2 by 2 meter table solution to build this on an optical table. And nobody was thinking this can be turned into a practical sensor. So our solution now is 2 by 2 centimeter, and we have the first 150 orders for this system from the German government to investigate the soil for new developed areas. And the second application field is based on diamond NV centers. I think this is a very popular field at the moment, but the question is what you build with it. We're also building a magnetic field sensor, but I don't want to point out it's very sensitive or very, let's say, high precision. This is all possible. People wrote papers about this, but so our sensor has one unique feature, and this is this behavior of the magnetic field versus the fluorescence modulation, and you have one feature which always occurs at the same field. So that's the reason why you can use it as a calibration-free sensor in applications. And the most attractive application which we have is at the moment smart meters. So there are companies, especially energy is an important issue, electrical energy at the moment, and they are afraid of people manipulating their meters, and they want to use different systems, not the classical magnetic system. They say this diamond-based magnetic field sensor has two features. First, it has this calibration-free operation, and second, it is physically much more complicated than the other system. It's based on some light, some optical detector, and so on. It's not so easy to manipulate. So we also have the first 1,500 orders for this sensor. So it goes into real applications. And the third one is based on solid-state circuits, so superconducting electronics. It's something I also gave a presentation on it. And it's a little bit harder to say how many let's say, devices have been ordered by someone, but our business case is not selling the solid-state circuits based on Josephson junctions. In this case, our business case is system integration. So we offer flip chip assembly, smart attachment of optical fibers to the system. So it's very, let's say, classical, but very dedicated assembly and packaging for quantum systems. And I like to end this contribution with maybe two goals or two motivations I like to address, maybe on one side to leaders of groups and also to PhD students. I think the future of the world is not steered by politicians. We need engineers and scientists, so we need to motivate young people to go into engineering and science. Quantum technology is a very attractive field to motivate them. And then when we have more and more, at the moment there's a strong demand. We need people, I would immediately hire people if I had, but we need to motivate the young people to go into this field. And I remember 20 years ago, they said, oh, no nuclear power. So a lot of physics students say, okay, what should I do now? So this motivation is important, but also we need to find applications for quantum technology which are maybe addressable in 2 or 3 years by first applications. Because otherwise we risk that we have, after this huge increase of funding right now, we have a valley after that, and we cannot show some success. So thank you.